Hello all. Previously we have seen arithmetic and relational operators in C programming. Now in this video we will see logical operators in C programming. Logical operators are used to combine multiple conditions. So if the conditions are true, it will return 1. If the conditions are false, it will return 0. So there are three operators in logical operators. The first one is logical AND, denoted with two ampersand symbols. So second one is logical OR, denoted with two pipe symbols. The third one is logical NOT, denoted with exclamation mark. So of which logical and logical are binary operators. So it will require two operands as input. When it comes to logical NOT, it is a unary operator. It requires only one operand as input. Now let us see how these are working. Now let's see this truth table of logical operators. We have three different operators, right? Logical AND denoted with two ampersand symbols, logical OR denoted with two pipe symbols, and logical NOT denoted with exclamation mark. Now let us see how these are working. Now for example, logical AND and logical OR, these are binary operators. So it requires two operands as inputs. For example, A and B are input variables. So if A is 1 and B is 1. So in C programming, any non-zero value is considered as true. I repeat, in C programming, any non-zero value, that means 1, 2, 3, 4 or minus 1, minus 2, minus 3, these are other than 0 is considered as true. 0 itself is considered as false. Okay. So now let us see this example. A is 1 and B is 1 and logical AND of A and B is 1. So when it comes to definition of logical AND, it will return true only if both operands are true. So it will return true only if both operands are true. If any one is false, the result is false. Okay. So A is 1 and B is 1. A and B is 1. A is 1 and B is 0, because if any one is 0, the result is 0 only. So A and B is also 0. 0 means false. So A is 0 and B is 1. If any one is 0, the logical AND gives you 0 as a output. If both are 0, logical AND also returns 0 as output. So this is how logical AND will work. So when it comes to logical OR, it is a binary operator. It requires two operands as input. So it will return true if any one of the operand is true. Only it will return false when two operands are 0. Okay. So if A is 1 and B is 1, the logical OR between A and B is 1. A is 1 and B is 0. As per the definition, if any one operand is true, the result is true in logical OR. Okay. So A is 1 and 0, the result is 1. 0, 1, any one of the operand is true. So that means A logical OR gives you 1 as output. It will return 0 only if both are 0. So A is 0 and B is 0. That means logical OR between A and B is 0. Only in this case, the 0 will come. Remaining 1 will come in logical OR. When it comes to logical NOT, that is denoted with exclamation mark, it is a unary operator. It will give you 1 as 0, 0 as 1. That means if true is given as input, it will return false as output. Vice versa. If false is given as input, it will return true as output. So that is the meaning of logical NOT, and it is denoted with exclamation mark. Now let us try to solve one example and then we will code it in the Dev CPP. Now let's see some examples to understand logical operators in better way. So we have three inputs variables, A is equal to 10, B is equal to 20 and C is equal to 10, and we have some condition. After evaluating, what is the result? So that is the meaning of this table. Now let's see one by one. So on line number 1, so at very first place we have A is equal to 10 and B is equal to 20 and C is equal to 10. Now we have one condition. So as per the definition of logical operators, it can combine the multiple conditions, right? So like that we have studied in the previous slides. So A greater than B is 10 greater than 20, is 10 greater than 20, no, right? So the result of this particular expression, what I am highlighting now, that is 0. So as per the definition of logical AND, the both operands or both expressions should be evaluated to 1. So this should be 1 and this should be 1. But at very first place only we got 0. So even though the next operation, so what I am highlighting now, A double equal to B is true. But in this case it is not true. Now let us, for God's sake, A double equal to B is also true. Now let us see. So now we got 0 at the first place, right? So 0 and 1. Even though the next operand is 1, it doesn't matter. Because logical AND needs two operands as 1. Because needs two operands as true statements only. So the compiler won't check for this evaluation. It will directly return 0. Okay. So A greater than B is 10 greater than 20. No, right? So the result of this particular expression is 0. The next operation cannot be evaluated because of even though that is evaluated, it does not make any sense. Even though that is 1, 0 and 1, 0 logical and 1, it anyhow result in 0 only. So compiler skip the next part. Okay. So the result is 0 here. Now when it comes to the second example, A is equal to 5 and B is equal to 2 and C is equal to 10. So in the very first place, A greater than B. Is 5 greater than 2? Correct. Compiler will check for the another one as well because it will depend on the second operand. Both operands need to be 1, right? Otherwise, then only we will get the result as 1. So the compiler will check for the second operation as well. So C greater than B is 10 greater than 2. The condition is correct. 1 and 1. So logical AND will return true if both operands are 1. So in this case the result is 1. Now let us see the third example. A is equal to 10, B is equal to 20, C is equal to 10. Now in this case we are using logical OR denoted with the 2 pipe symbols. Now A less than B is 10 less than 20. Yes, condition is correct. Is 10 less than 20? Condition is correct. So the answer is 1 in this place. So even though the next operation is 0, that does not matter because anyhow the result is 1. So as per the definition of logical OR, any one of the operand is 1, the result is always 1. Okay, so the compiler will skip this. So the answer is 1. So for God's sake, let us try to evaluate this also, this as well. So 20 greater than, so B means 20, right? B 20, 20 greater than 10, this is also right. So 1, logical OR 1, the result is 1. Now let us see another example. A is equal to 1, B is equal to 2, C is equal to 10. Now A less than B, 1 less than 2, 1 less than 2, condition is true, or C greater than B, 10 greater than 2, both are right. So answer is 1. So A is equal to 10, B is equal to 20, C is equal to 10. A greater than or equal to B, that means 10 greater than or equal to 20. 10 greater than or equal to 20, the condition is not satisfied and we will move to the C greater than B. 10 greater than 20, this is also false. 0, logical OR 0, the answer is 0. Okay, logical OR will return 0 if both operands are 0. So in this case the result is 0. Now let us go for the logical NOT, that is a unary operator. So it will operate on only one value, right? So only one expression value. So A is equal to 20, B is equal to 20, C is equal to 10. So now let's calculate this part. 20 less than or equal to 20. 20 less than or equal to 20, the condition is true only because we have given equal to is also right. 20 greater than or equal to 20, the answer is 1 only. the inverse of 1, because 1 will gets converted into 0, 0 converted to 1. So logical not of 1, 1 will invert it to 0. So that is how 0 came here. So A is equal to 20, B is equal to 20, C is equal to 10. Now let us see this calculations, what I am highlighting now. C greater than D is 20, is 10 greater than 20? No, right? 10 is not greater than 20. So answer is 0 and we are inverting it. So answer is 1. Now let us see these examples in Dev CPP. I have written the code for that. So now let us compare these results in Dev CPP. So let us try to hard code these values. Now A less than 20. Okay, fine. So in this case, I have written one code to accept 3 input values, A, B, C values, and we are taking the input from the scanf function. Since these 3 are in integer data types, so the format specifier for integer data type is %d. That is why 3 %d symbols are given. So whatever the user enters, those values are stored in the memory locations of A, B, C respectively. Now let us see A is 10 and B is 20 and C is 10. Now let us calculate these conditions so that we can understand in a better way. So now let us see A greater than B. Is 10 greater than 20? Is 10 greater than 20? No, right? So the answer is 0. No need to calculate this, because even though it is true, that doesn't matter, because we have already 0 here. So answer is 0. Now let us come to this part, A greater than B. So now let's see. This is also won't make any sense, because this is always 0. So now in this place also 0. Why? So A greater than B. That means 10 greater than 20. No, right? 0. Don't check this condition. Doesn't matter. Now let us come back to this expression. A less than B. Is 10 less than 20? Answer is correct. So even though this is false, anyhow the result is true. So this will come as 1. A less than B, this is also 1. Why? This is itself is true only. A less than B is true only, right? That is why 1. So even in logical OR, any one operand is true, the result is true. The compiler won't check for the another one. This point you should remember. This point is very, very important. Some tricky questions might be asked in the interview. We will show you those examples after we complete the unit 1. Okay. So A greater than or equal to B. Now 10 greater than or equal to 20. 10 greater than or equal to 20. Is 10 greater than or equal to 20? No, right? The answer is 0 here. Now let us come to this expression. A greater than or equal to B. A less than or equal to B. Is 10 less than or equal to 20? The answer is 1. But we have to invert. So answer is 0 here. So is C greater than B? C value is 10. 10 greater than 20? No, right? So answer will be inverted. So 1 will be the answer. So let us try to run this code and see how this works. So A value, B value, C value. So what I am checking 10, 20, 10. So let us try to compare these values 0, 0, 0, 0, 1, 1, 0, 0, 1. So whatever I am expecting in comments, those are displayed as output. This is how logical operators works in the C programming. So logical operators can combine multiple conditions so that we can code it in the better conditions in the coding. So there is a concept of flow control in which we can extensively use logical operators. So the knowledge of logical operators is very much useful to code it in the better way. So that's it for this video. I will see you in the next video. Thank you so much for watching.